Let's practice solving linear systems of equations by using the elimination and substitution methods together. In this particular video, we have 8 different practice problems, and sometimes using elimination is going to be a little bit more efficient, and sometimes using substitution will be. Keep in mind that some of these systems may have no solution or infinite solutions. Real quick, before we get started, if you'd like to download a free copy of this PDF, you can find a link in the description box below. You can also find an annotated or detailed answer key there as well in case that's helpful. Alright, let's get started. For number 1, we have 2x plus 5y equals 14 and 6x plus 7y is equal to 10. Now because both of these are written in standard form and they all have different coefficients, I'm going to go ahead and start by using elimination method just because it's hard to isolate a variable here. Now 6 and 2 are going to meet at 6 for the first time, and then 5 and 7 are going to meet at 35 for the first time. So I'm going to go ahead and choose to eliminate the x terms here. So I'm just going to go ahead and highlight them that I'm going to be working with those. Let's work on eliminating these x terms. Alright, first we're going to go ahead and multiply this top equation by 3 all the way across. By multiplying the whole top equation by 3, we're going to get 6x plus 15y is equal to 42. We're not going to go ahead and really do anything with the bottom equation just because we already have a 6, but if you really want to write it, we can say we're going to multiply everything by 1, but that's just going to stay the same. We're going to get 6x plus 7y is equal to 10. This is going to be the new system that we're going to use here. Alright, cool. So now we have these 6 x's that match, and if we want to go ahead and eliminate these terms, we're going to go ahead and subtract them, right? If we subtract 6x minus 6x, they're going to get eliminated. Then if we go ahead and take this 15y and then subtract 7y, that's going to equal 8y. And then finally, if we take on the right side this 42 and take away this 10, we're going to get 32. Then if we divide both sides by 8 here for one final step to solve for y, we're going to see that y is going to equal 4. Now that we found y, let's go ahead and use that information to solve for x. You can either plug it into the top or the bottom equation. I'm just going to go ahead and plug it into the bottom equation here. Okay, so substituting that in, we're going to have this 6x plus 7 multiplied by the 4 that we just got. Go ahead and substitute that in. That's going to equal 10. Multiplying 7 times 4, that's going to equal 28. So we're going to have 6x plus 28, and that's equal to 10. Then we have this two-step equation. Let's go ahead and subtract 28 from both sides. Subtracting 28 from both sides, we're left with a one-step equation. We can write 6x is equal to negative 18. And then finally, dividing both sides by 6 here, we're going to find out that x is going to equal negative 3. Now that we found x and y, let's go ahead and write our solution of negative 3 comma 4. So these two linear equations would intersect over in quadrant 2. Here's number 2. For number 2, we have the equation 16x plus 2y is equal to negative 2, and y is equal to 8x minus 1. Now keep in mind this y is already isolated, so this is a good candidate for the substitution method, but I'm also noticing something about equation number 1 on top, that all of these are divisible by 2. Now, a few things you can do here. This is totally optional to go ahead and do this first step, but what I feel like doing here is just taking this whole thing and dividing it by 2 first, just so we can deal with smaller numbers. So if you notice that, then great. If you don't notice that, that's totally okay. I just would like to use smaller numbers when I can. So dividing everything by 2 here in that top equation, we're going to get 8x plus 1y is equal to negative 1. Okay, so let's go ahead and see what we're going to do next here. Now notice how this y again is equal to this expression of 8x minus 1. So let's go ahead and maybe make a substitution and replace this y in the top equation with that expression. So making that substitution in, we're going to have 8x plus, and instead of y, we're going to go ahead and write that expression on the right side of 8x minus 1, since that's the same thing as y. And this is going to be equal to negative 1 on the other side. Now we have a plus sign in front of the parentheses, so we're really distributing a positive 1, so that's not going to have an effect, so we can just go ahead and drop the parentheses here and just rewrite this equation. And now we just have an equation with one variable, so this is going to be able to solve. Let's go ahead and combine these like terms of 8x and 8x. That's going to get us a total of 16x minus 1, and that's going to equal the negative 1 on the other side. Let's solve this two-step equation. Let's go ahead and add 1 to both sides first. By adding 1 to both sides, we're going to get 16x is equal to 0. And then dividing both sides by 16, we find out that x is equal to 0. Now that we know x is equal to 0, I think the easiest thing to do is substitute it into this second equation or bottom equation to solve for y, since y is already isolated. So if we go ahead and do that, we're going to have y is equal to 8 times this 0 that we just found for x. So go ahead and write that 8 times 0 minus 1. Now 8 times 0 is just going to be 0, so we're going to have y is equal to 0 minus 1. 0 minus 1 is negative 1, so now we have our y value. So we have x and we have y now, so we know our solution is going to be at 0, negative 1. That would be the location where these two linear equations intersect each other on the coordinate plane. Alright, cool. So in number 1 we used elimination, and in number 2 we used substitution. Let's check out number 3 now. For number 3, it looks like everything is lined up pretty nicely. We have 3x minus 2y equals negative 5, and 4x plus 5y equals 47. They're both in standard form, and it doesn't look like we can really isolate any variables easily, so let's go ahead and use the elimination method. Now, when do 3 and 4 meet for the first time? Well, their LCM is 12, versus the 2 and 5, they're going to meet at 10 for the first time. So these are both pretty close, totally up to you which ones you want to make, match here. So I think because the bottom equation has a 47 in it, I'm going to go ahead and just multiply the bottom equation by 2. So we're going to get 10y, and we'll multiply the top equation by 5, right? So let's go ahead and see if we can eliminate the y's here. For this top equation, let's go ahead and multiply that whole thing by 5. If we multiply everything by 5 up there, 3 times 5, that's going to be 15x first. Then we're going to get minus 10y, and then negative 5 times 5 is equal to negative 25. All right, what about that bottom equation for that bottom one? Let's go ahead and take that whole equation and multiply it by 2. All right, so 4 times 2, that's going to get us 8x. And then 5 times 2, that's going to get us positive 10y, so plus 10y. And then 47 times 2, that should be 94. Okay, so again, I wanted to go ahead and just eliminate the y's here, so we wanted to make their coefficients match. So again, these y coefficients were different, but we went ahead and rewrote these equations so they have matching coefficients. Now, to eliminate these y terms, let's go ahead and add these two equations together, just because the negative 10 and positive 10 are opposites and they add to get 0. 15x plus this 8x is going to leave us with 23x on the left side. This negative 10y plus 10y is going to eliminate as we had planned. And on the right side of the equation, negative 25 plus 94, that's really just 94 minus 25, and that's going to be equal to 69. Now, one final step for this equation. Now let's go ahead and divide both sides by 23 to solve for x, and 69 divided by 23 is going to equal 3. Now that we know what x is equal to, let's go ahead and use that to find y. I'm going to go ahead and plug it into this top equation just because we have some smaller numbers there. Okay, so we're going to have 3 multiplied by, we got x is equal to 3, so we'll have 3 times 3 first here, minus this 2y, and that's going to equal negative 5. Okay, now 3 times 3, that's going to equal 9, so we're going to have 9 minus 2y is equal to negative 5. Now let's go ahead and solve this two-step equation. First, we'll start by subtracting 9 from both sides here. And when we do that, we're going to be left with negative 2y is equal to negative 14. Then finally, dividing both sides by negative 2, we're going to see here that y is going to equal positive 7. Now that we know our y value, we can go ahead and combine it with our x value and say that our solution here is going to be 3, 7 over in quadrant 1. Here's number 4. First, it's good to know that this top equation can't be simplified at all just because all of these terms are relatively prime with each other. When we took a look at the second equation on the bottom here, notice that y is isolated, so maybe this is a good candidate for using substitution. All right. Now, since y is isolated already at the beginning and then it's equal to this x plus 0.6, let's go ahead and make a substitution and replace the y, or substitute the y in the first equation with this expression of x plus 6/10. If we go ahead and do that, we're going to have this 5x minus 5 times the quantity of this x plus 0.6, just like this, and that's going to be equal to the negative 3 on the other side. Then we can go ahead and distribute this negative 5 to both of these terms in the parentheses here. So this 5x in the beginning is going to stay the same. Then we're going to have minus 5x, and then we're going to have a minus 3 afterwards. That's negative 5 times 0.6, and that's going to be equal to negative 3 on the other side. On the left side, we can clean this up by taking this 5x and take away this 5x, so that's going to be 0x. So we're actually going to be left with this equation of negative 3 equals negative 3. Now, if you ever get this and it is a true statement, because negative 3 does equal negative 3, then we can go ahead and say that we know there are going to be infinite solutions for this system. If you happen to get a false statement here, where we got something like negative 3 equals 5, which is a false statement, then we know that these two lines would be parallel to each other and there would be no solution. So for this particular system, these two linear graphs would lie right on top of each other, and there would be infinite points or infinite solutions that would satisfy both equations. Here's number 5. For this system, we have x minus y is equal to 0, so we have some coefficients of 1, which are easy to work with. Then we have 5x minus 2y is equal to 6. Now, both of these equations are written in standard form, so that's kind of nice for elimination. While it wouldn't be too much work to try to isolate the x or the y for this particular problem, I think I'm just going to stick with elimination just because I like how everything is lined up, and it's going to be pretty easy to get some coefficients to match here. My preference for this example is to make these coefficients for y to match here. So I'm just going to go ahead and multiply this top equation by 2, and that way we would have 2's for the coefficients for the y. So multiplying that whole top equation by 2, we're going to get 2x minus 2y is equal to 0, since 0 times 2 is still 0. And we're going to leave that bottom equation alone because we already have that 2 or negative 2 as a coefficient. So let's go ahead and use this new version of the system and use elimination here. Now keep in mind that we do have a negative 2y and a negative 2y, and since those negative 2's match, we're going to go ahead and subtract them to make them eliminate, right? So this 2x minus this 5x, that's going to equal negative 3x. And then if we take this negative 2y and subtract a negative 2y, those are going to eliminate and get 0y. And on the right side, we're just left with 0, take away 6, which is going to equal negative 6. To solve this one-step equation here, let's go ahead and divide both sides by negative 3. If we do that, then we're going to be left with x is equal to positive 2. Now that we know x, let's go ahead and use that to find out the y value. I'm going to go ahead and plug it into this top equation because it looks a little bit less complicated. And so if we plug that in, we're just going to have this 2, and we're going to take away y, and that's going to equal 0. Now to solve this equation, let's go ahead and subtract 2 from both sides. When we do that, we're going to be left with negative y is equal to negative 2. And then we can go ahead and divide both sides by negative 1 or multiply both sides by negative 1. Either way, we're going to find out that y is going to equal positive 2. Now that we know what x and y are equal to, we can say that our solution here is going to be at 2, 2 over in quadrant 1. Here's number 6. For number 6, we have the equations x minus 2y is equal to 7 and negative x plus 2y is equal to 7. So these two equations look very similar. It's important to notice right away that both equations are in standard form, so elimination is a good candidate here. But also keep in mind that we know that the coefficient for this x is 1, while this coefficient is negative 1, so those could eliminate right away. And this negative 2 and positive 2 coefficients can eliminate right away as well. Here I just copied down these equations just so I can show you these two that we could eliminate. Again, we could go ahead and add these two to eliminate the x terms over here, or we could go ahead and add these two and those would also eliminate. So watch what happens here. It's pretty interesting. So if we add these two equations together, notice what's going to happen here. If we have this 1x plus a negative 1x, those are actually going to eliminate. We're going to have 0 x's. But then when we go ahead and add this negative 2y and positive 2y, they actually also eliminate. When this happens, that means that we're going to have 0 on the left side of the equation. On the right side, we have 7 plus 7, and that's equal to 14, right? Now, if this is not a true statement, then we have to put a slash through this equal sign. And since this is false, it lets us know that we have no solution for this system of linear equations. Again, if you got a true statement like 0 equals 0 or 14 equals 14, that would mean that these two lines are on top of each other or they coincide, which means they're infinite solutions. But if you ever get an inaccurate statement or a false statement like this, that's just not true. That means that the two lines are parallel to each other. If you want to go ahead and graph them, you should see, because they have the same slope but different y-intercepts, that these two lines would never intersect. Here's number 7. For number 7, we have the equation negative 18x plus 6y is equal to 24, and 3x minus y is equal to negative 2. Now right away, looking at this top equation, I'm noticing that this 18, 6, and 24 can all be divisible by their GCF of 6. So just to make these smaller, I'm going to go ahead and divide everything up here by 6 just to get started. So if we go ahead and divide everything by 6, on the top equation, we're going to get negative 3x plus y is equal to 4. Okay, the bottom equation, I'm not going to do anything with that. I'm just going to keep this as 3x minus y is equal to negative 2. And let's go ahead and just use this new system here with some smaller numbers. So since they're both in standard form and they're lined up and they have matching coefficients, let's just go ahead and add these right away. if we add this negative 3x plus this positive 3x, they're just going to get eliminated. And then if we add this positive 1y and negative 1y, those are also going to get eliminated. So on the left side, we're going to be left with this 0. And on the right side, if we add 4 plus negative 2, or just 4 minus 2, that's going to equal positive 2. So again, this is a false statement, so this means that these two lines would also be parallel to each other. Since this is a false statement, we can say that there is no solution for this system because these two linear equations would never cross each other. For this one, we have the equations 4y plus 5x is equal to 15, and x is equal to 8y plus 3. So we can't simplify any of these equations, we can't divide any of them by their GCF since they're all relatively prime, but please notice right at the beginning about the second equation. For the second equation on the bottom, notice how x is already isolated and it's equal to this 8y plus 3. So let's go ahead and use substitution. This is a great one to use substitution for, and swap out the x in the top equation with the 8y plus 3. So if we go ahead and use the substitution method here, we're going to have 4y plus 5 multiplied by this quantity of 8y plus 3. Okay, we're just swapping that out or making that substitution, and this is going to equal the 15 on the other side of the equation. Okay. Next, we're going to go ahead and distribute this 5 to both of these terms on the inside. When we do that, we're going to have 4y plus, this is going to be 40y, and then 5 times 3 is 15, and this is going to be equal to 15 on the right side. Combining these like terms of 4y and positive 40y, we're going to have a total of 44y on the left side, plus 15 is equal to 15. Solving this two-step equation now, let's go ahead and subtract 15 from both sides of the equation. When we do that, we're left with 44y is equal to 0. And then dividing both sides by 44, we're going to see here that y is going to equal 0. Now that we know that y is equal to 0, let's go ahead and use that to find the value of x. Let's go ahead and use the second equation, or the bottom equation, just because x is already isolated, so that's going to be the most easy one to use. So we're going to have x is equal to 8 multiplied by y, which we found out is 0, so 8 times 0. We're going to have plus 3 here. Now 8 times 0 is just going to equal 0, so it's going to be x is equal to 0 plus 3. 0 plus 3 is equal to 3, so we know that x is equal to 3. Alrighty, so now that we know x and y, we can put them together to write our solution of 3, 0. So these two linear equations would intersect on the positive x-axis. So there you have 8 different practice problems dealing with solving some linear systems by using either the substitution or elimination method. Some of these systems had one solution while others had infinite solutions or no solution, and you can see that in different types of problems, elimination method might make more sense if they're written in standard form and it's easy to get the coefficients to match, whereas if a variable is already isolated and has a coefficient of 1, using substitution might be a little bit more efficient. If you found this video helpful in any way, please consider giving it a thumbs up and sharing with other people. As always, keep with the great work that you're already doing, and I'll see you in the next one.